All right. Hello, YouTubers. We're back. This is part 6 of the restoration of the Traynor TS-15 guitar amplifier. The first thing I want to show you is, if you remember in the previous videos, we talked about during the restoration, we have to do the hard part, and we have to clean the entire case, the front and everything like that. So what I've done here, and in my experience, you want to really be careful, because I've tried harsh chemicals sometimes when I clean stuff, and what it did was actually wiped out the lettering of what I'm restoring. So you don't want to do that. So start with something really simple, like what I did with this. I actually put this whole entire unit in my sink, got a little hot water and some soap, and just gave it a good scrub with a scrub brush, because I knew, that wasn't going to take away any of the lettering or anything like that. And then once that's done, if you're not satisfied, then, you can always go around a little bit with some better chemicals, but stay away from the lettering. The last thing you want to do is ruin that lettering, because now you don't have a good faceplate, or you don't have, a whatever project you're doing, you destroyed the lettering, so you're pretty much screwed. So that's where I'm at with that. The case is actually still down here. I'm going to finish vacuuming that. And what I'm going to do with this case and the front plate is I'm just going to use some, Armor All protectorant. And that should do the job. It's not harsh enough where it's going to remove lettering. Just spray it on, give it a little wipe, and it'll bring out that, this black stuff, whatever they call that they put the case in. And this faceplate, it'll bring it up a little bit, make it more black, and that'll be good. So, all right. Hello, people. This is actually part 6 of the restoration of this Traynor guitar amplifier. If you're watching this, the video ended because for some reason my phone decided to end it. So we're going to come back and we're going to talk about a couple things, like, the components that I purchased to do this job. Now, if you look at all these cases, none of these cases cost me more than $20. So if you're going to do a restoration and you want to do a practical restoration, like I said in my previous videos, I want to make this guitar amplifier functional for the next person who owns it, so he can play it and it'll play again, hopefully for years. So a couple things I want to go over right now. One of my viewers, his name is Mike, he put in his comment where I made an error. And if you go to part 2 of the video, make sure the closed caption is turned on, you'll see what he was talking about. He was right. One of the power resistors that I was talking about, which is this one, if you'll notice, it's R51. So what that means is it's 0.51 ohms, not 51 ohms. It's 0.51 ohms. And when I started thinking about it, I said, you know what? He was right about that, because some of the resistors that, I have in my collection right now, I wasn't sure why. Like, here's one right now. And you'll see that says 4B7. So what that actually means is it's 4.7 ohms. And I have my leads connected to my digital multimeter, and I'll show you right here. If you look, it is 4.7 ohms. So where they place that letter is actually very important. And, again, I thank Mike for watching my videos, and I thank Mike for pointing that out in the comments. I'm humble. I'd rather people make some comments. If they're right, put it in the comments and I'll look at it, and he was right. What he was right about is, if we go back to this resistor, it says R51. So it's not, in my previous video, I thought it was a 51 ohm resistor. It's not. It's 0.51 ohm resistor. And now I'll show you. And actually, you know, if you guys have watched the previous videos, this is now complete. And you know what? I had it up on screen. Give me a second. I want to bring the before and after picture back up on screen so you guys can see what we have done so far. Give me 1 minute. Not that one. We're getting closer. Okay. Now, if you look on my computer screen right now, you'll see the before board. And then you'll see the after board. So let me point out a couple things that I have done. And I'm sorry for how long it took for these videos to, you know, come on to YouTube, but I had to wait for components to come in. So obviously the big capacitors have come in. Those are going to replace those orange capacitors. And if you watch my previous videos, you'll see these. Some are called rainbow, some are called tropical fish, and you should be very familiar with these. These are ceramic capacitors. So if you look at the new board now, the new board now has all the tropical fish, whatever you want to call them, capacitors all replaced. Let me get a close-up. These two guys here are ceramic capacitors that are now replaced. And as far as I can tell, you know, we did some testing. I think this is okay. All the diodes, all the resistors tested out to be okay. We now have the proper power resistors in place. And I think the next step that I'm going to do, I have a variac on order because I don't want to plug this in and just give it a full jolt of 120, 15 amp power. So I think we're going to bring this up to speed with, you know, do it the right way. Get yourself a variac. I looked online, and for the most part, what I found is a good variac only costs about maybe $70. But to me, you know what? That's a good investment. Because if you can see, I've already made some investments. I got my power supply. I got my oscilloscope. I got, those are actually, this one down here, this is actually a digital multimeter, but it has so many functions. And I can inject signals with these two components. I have desoldering tools, SMD tools, all that stuff. And if you'll look, I don't know if you can see the numbers, but you can get all these, you know, pieces of equipment pretty cheap. And you can build yourself a nice lab pretty cheap. That's what I did. I mean, I'm not rich. I don't have a lot of money, but over the course of time, I bought these components to help me do what I'm doing right now. And it helped a lot. And I can't stress enough. Thank you, Mike. When I put these videos out, I encourage the comments. You know, look what I'm doing. If you see a mistake that I made, point it out. That's what happened, you know, on this board repair. Because if you think about it, 51 ohms versus 0.51 ohms is a major difference. I mean, I might have been scratching my head trying to figure out what the heck went wrong. But thanks again, Mike, for pointing that out. Real quick, I'll go to the schematic again, and what he saw is this. OR51 5 watt. Now, if you see 5 watt, that means it's a power resistor. But what he pointed out was OR51 was 0.51 ohms. So the R is important. And like I said before, I actually set this little demonstration up, is if you can see that. Let me see if I can get it. It's 4B7. What that means is 4.7. So again, I might be repeating myself, but you know, pay attention. This is so important. And you know what? When you take components out, test them. You never know. It might be good, and it'll, you know, give you a little indication of, is the part that you're going to replace the right part. So again, I don't want to go on, but you know, here's all the things that I've purchased. Like I said, these little kits are less than $20, but you know what? I'll be able to do a lot of restorations with these kits. So we'll be back soon. Thank you. Okay, just wanted to do a quick little clip of where I'm at with this board. I'm going to go over it later, you know, do a recap of everything that I did. As you can see, all the components that were bad have now been replaced. This little clip, what I want to talk about is the cleaning process. After I redid this board, there's a lot of flux from, you know, doing the soldering and stuff like that. I recommend, and in my personal experience, don't leave that flux on there. Number one, it doesn't look good. Number two, it actually can cause some problems. I saw some videos on YouTube where, you know, leaving flux on the board can cause problems. So what I'm doing here, and I'll give you a little demonstration. Don't be afraid. You know, this is done. There's no electrical connection. So, you know, I'm giving it a good bath of IPA. You know, get a little toothbrush or something like that. Scrub it all down real good. And once you feel like it's, you know, nice and clean, flip it over. I'm going to flip the board over. And as you can see, I've already done quite a bit of cleaning. You know, don't be afraid to give it a good bath of IPA. Scrub the entire board. Because like I said, you know, once you're finished, it's going to look nice to you and, you know, in the YouTube video or whoever's going to buy this amplifier. So what I do recommend is, I think I've already showed you in my lab, I have quite a bit of you know, tools that I use. Right now what I got running is my desoldering, I'm sorry, not desoldering, but my soldering SMD workstation. So I have hot air, and in this case, you know, just give it enough heat to dissipate the IPA. So what I'm going to do is, once I scrubbed it real good, and it doesn't take much, as you can see, that heat gun will... Alright, let's do a little repair work. As I showed you before, what we're going to be hitting right now is, you'll notice this little joint here, this joint here. Let me see if I can flip this over and show you what that... Look at these two joints here. This joint right there. And we'll see on the other side that it's actually a jumper wire. And if I move it a little bit, you should see it's not even tight. So what we're going to do, and if you notice, on the one side of this jumper wire, probably something that I did when we were doing the repair, we lifted this pad off. So this needs to connect to here. It's not too far away, so let's see if we can just build a little solder over to it, get this done, and get that joint tight. Like I said, we want to make sure our joints are tight. This one over here, we're going to hit this one too. Over here, sorry. On the other side of the board, this is one of those blue capacitors, and it is actually loose, so we want to make sure we get a tight joint on that. So, again, don't be stingy with the flux. I use a lot of flux, and what that does is make sure that our solder flows real nice, gets in the joint. So let's hit this one first. Now what I do, just touch it, get rid of that blob of, or let's melt that blob of flux, and then we can see what we're doing. So as you can see, it don't take much. Heat that joint up. Then we can hit it with a little solder. Now this is the one I was talking about where we're going to have to try to bridge from this little joint over to where it was supposed to be connected. So let's hit it with a little bit of solder. Let's try to bridge the joint over. And it doesn't look like we're going to be able to, so that's not a problem. What we're going to do is just lay a little piece of wire across that and we'll get that fixed. So let's move on to this other one over here. And we'll make sure that we have a nice tight joint on this. So just lay your soldering iron on there. Just like that. That's it. Actually, you know what? Since we're on the subject of, talking about soldering and stuff like that, this tip that I have on here right now, I'm not sure what size it is, but you could probably get an idea. This is my go-to tip. This is the tip that stays on my soldering iron probably 95% of the time. Now, I do have other tips. I'll show you some. And you are going to want to get some other tips, because you'll need them for different projects. There's some. Here's some here. Some other tips. But this guy right here, that's my go-to tip. It's not too small, not too big, but, for most of these projects that I do, this tip serves me well. Another thing I want to talk about is, you'll watch some videos and there'll be some videos out there that people swear by. You have to buy this tip cleaner and tip rejuvenator, stuff like that. I'm not going to discourage you from doing that. By all means, do whatever you want to keep your tips clean. But here's what I do. This tip has served me well for over a year. And the only thing that I do is, let me bring this. You definitely want to have this. This is your tip cleaning braid, brass, whatever they call it. Always when you're soldering, you want to dunk your soldering tip into that. Keep it clean. Let me see if I can bring this into the picture. Yeah. Keep it clean. And what I do when I'm doing a project, all I do is always keep some fresh solder on the tip. And you'll see that there might be a little blob. Give it one little dunk in the cleaner. See that? It's got fresh solder on it. Put it in the holder. Now the same thing is when I'm finished and I go to turn my soldering iron off, I do the same thing. Clean it off. Get it a nice blob of solder on that tip. Give it one little dunk. Make sure the fresh solder is staying on that tip. Then shut your soldering iron off. And what that does is it's doing what all those tip cleaners claim to do. It's keeping the tip from oxidizing. It's keeping it clean. And when you go to start a new project, you heat your soldering iron up, and there's already solder on there that's keeping it clean. And you'll just, when you start your new project, wipe it off, put a little dab of fresh solder on it, wipe it off again, and go to it. And like I said, this tip has served me well for over a year. I have no problems whatsoever. All right, and we will be back.